Hello everyone. In this video, we're going to look at the three traversal algorithms in terms of Python codes. So the first algorithm that I'm going to go through is the pre-order traversal. So here it is pre-order traversal. So as a reminder for the algorithm, when you use pre-order traversal, what you do is you visit root and then you visit subtrees from left to right. Now we're going to define this algorithm just because there's no built-in function for pre-order traversals. So we're going to define a function, so pre-order, and we're going to take in two inputs. That is the tree, which we're going to set up later, and the tree that we're going to use is this tree, and this is similar to the example in lecture 14 that we have. Now, the second input that we need is the node or the root that we're going to visit at different level. So I call this nodes. After defining the functions, you need to colon and then go to the next line. And in the next line, what you do is that you want to output the root that you are visiting, right? Because for the algorithm of the pre-order traversal, you visit root first, so you need that information first. So you print out the node that you visit, and you do n equal to. So for this line of code, what you do is you output the current vertex, or in this case, the root that we are talking about. And this particular information right here is that we want the answer later appear in a single line. So that's what you have. Now, after visit the root, you're going to visit the subtrees from left to right. So what you do is I'm going to look into this tree and see what I have for the subtree. And I'm going to define the child of the root that I have. This child means that I'm going to see what subtrees that I'm working with in tree, and you're going to get the nodes that you are working with. So after this line, you need to colon, and then you're going to do the pre-order of the tree, and the node is going to be the child that you are currently looking into. So in this case, you could look into the subtree with the root B, the subtree with the root C, and this subtree of the root D. If when you're looking at this root and there's more subtrees that need to be considered, this line of code say that do something. Now, when you look at the root and there's no other children or there's no other subtree after this root, then give me an empty list. So that's what it means. So for this for loop, it means that if a subtree is found, return the list of subtree or children for that matter. And in the case if a subtree is not found, return an empty list. Now for this line of code, what it means is that you want to perform the pre-order traversal on each subtree that you just found. And then that's it, really much that's it for the pre-order traversal. Now we need to set up the tree, and this is the tree that we're going to use. So I'm going here, I'm going to get out of the function in the for loop, and I'm going to define the tree, and I'm going to use dictionary to define the tree. So I have the root A here, and the root A will have the children of B, C, and D. So I'm going to define A, and here I have A has the children of B, C, and D. Now, next for B, I have the children of E and F. So B, now C, there's no children of C, so I'm not gonna do anything for C. Now for D, D has children of G, H, and I. So I'm gonna do D with G, H, H, and I. So next, so for E, E has a children of J and K. F has no children, but G has children of L and M. So I do G, I do L, M. So there's no children for H, there's no children for I, there's no children for J. But K, we have children of N, O, and P. So for K, I'm going to do N, O, and P. So that is the setup tree that we have in lecture 14. All right, so everything is set up. Now we need the output of the vertices in which we're going to visit using the pre-order traversal. So let me run the code here. All right, so output the result. What you do is you do pre-order and you type in the tree, and this is the tree that we just set up. And then node, because A is the ancestor of all the nodes in the tree. So I'm going to start with the node A. So run the code, and this is going to be the results that you have. And if you compare this with the nodes in lecture 14, this is going to be the exact solutions that we have. So to make it easier to read, what you can do is that in the print options here, you can space out this a little bit. So that when you run this again, you can see all the letters get spaced out. So that's the pre-order traversal algorithm. Now, the next algorithm I'm going to cover is actually the post-order traversal because the code is going to be simple enough to modify it based on the code that we just have. And then at the end, I'm going to cover the in-order traversal algorithm. So I'm just going to copy this informations and then paste it here. So what I'm going to modify in terms of the post-order traversal is that this is the function post-order. Still, I'm going to take two input, the tree and the node. Now for the post-order traversal, what you have is that you need to visit the subtree from left to right first, and then you visit root. So that means that this print options right here is no longer at this locations. What you do is that you need to visit the subtree first, and then at the end, you get out of the for loop and paste the print options here. Another thing that I need to modify is that it's no longer the pre-order functions, but post-order functions. So I'm just going to copy and paste here. And then we're going to run the code again because we're going to use the exact same tree that we have in the last code. Now for the output, I'm going to do post order, and I need to do the tree. And then also the ancestor of all the nodes in the tree is A. So I'm going to use the node A here, run the code. And then that is the results that you have now. You compare this result with the one that we have in lecture 14. They're going to be the same thing. Now I'm going to move on to the last algorithm, which is the in-order traversal algorithm. For the in-order traversal, what you do is that you visit the leftmost subtree, and then you visit root, and you visit all the subtree from left to right. So why do we wait until the end for the in-order traversal? The algorithm of the in-order traversal is slightly different from the other two, the pre-order traversal and the post-order traversal, is because originally in-order traversal is defined only for binary trees. So what is binary tree? So binary tree is the tree that just have two layers. So this is one layer, the top layers, and the bottom layer. So that means in-order traversal cover only two layers of this particular tree that we see on the screen. So that's why we have to modify, we have to do a little bit of work for the in-order traversal in order to get the results. So now I need to define the function in order. I'm going to take in the tree and the node informations as well. Inside this functions, what you do next is you look into the children or the subtree of the entire tree first, because you need to visit the leftmost subtree first before you visit root, and then you visit all the subtree from left to right. So I look into the children. And then how could I get that? Do tree dot get, then look into the node. So that is very similar to what we see earlier in terms of getting the tree, getting the node of the trees that you have. So this one means that I'm going to get the children of the current vertex or root. So the children here means subtrees. Now, what you do is you traverse the leftmost subtree. How could you do that? You say that if length of the children is greater than 0, then what you do is you apply the in-order traversal algorithm. So tree here, children, and you look at the first one, right, which is the leftmost one. And then you get out of this if statement, then you print the node with this informations. Right here, you visit the leftmost subtree. Right here, you go back to the root, right? So here you visit root. So output the root. And then you're going to visit all the subtrees from left to right. So for child in children, and then because you already visit the leftmost subtree, you start at 1, and that is going from the left to right. So here, what you do is you process the remaining subtrees from left to right, and then you apply the in-order traversal algorithm again. So tree, but here is the child that you're looking at. So that's it for the in-order traversal. You start out with looking at all the subtrees of the node A. Eventually, you're going to put A in here. But then you go and traverse the leftmost subtree, then visit the root, and then visit the remaining subtrees from left to right. Now, the tree that we have is similar to the last two codes, so I'm just going to copy and paste here, run the code. And then for the output, I do in order, and then I take in the tree in the node A and run the code, and this is the result that I get. Again, if you compare this result with the example in lecture 14 for the in-order traversal, they're going to be the same thing. Now, in terms of the assignment that we're going to have, what I'm going to ask you to do is just going to modify the tree so that you're familiar with the type of dictionary that we use and how to read the tree and how to run the code and understand the algorithms behind all of this tree traversals. So that's it for me for this video. Please let me know if you have any questions. Thank you.